Hello, welcome to Math. Let's look at this question. Find x if log 1296 base x is equal to log 256 base 4. Find x if log 1296 base x is equal to log 256 base 4. How is x going to be found? Or how are we going to get the value for x from this equation? Well, to find out, why don't we get started? So let's write our solution first. Okay, let's write our equation down here. Log 1296 base x is equal to log 256 base 4. Now, what we are going to do here is, first we are going to tackle this right hand side. We are going to look at what is here, and then as we are reducing this one, we continue maintaining this. Okay, because if you don't do it that way, and then as we are reducing this, we also reduce this at the same time. At the end of the day, solving for x will give you a problem because you have to still, wherever you have reduced this once, you have to go back to get this before you can take away what the log aspect in order to get the value for what x. So what I'm going to do is, we are going to look at this right hand side, and then you maintain this one, and then we carry it around, and then we work on this. After we are done working on this one, then we find a means to deal with the log and the base, which at the end of the day will go away, leaving what this one, so that we can find the value of what x. So log 256 base 4. Now 256, well, what can we do to reduce this one? The base is 4. The base is 4. So what can we do to reduce this one? Well, those of us who have when you punch this equation on your calculator, it will give you the value for what x, but when you are writing it, I don't think you just say the value for x from this equation is what, maybe 1, maybe 2, without what working it out, without what without anything backing your what answer. So we have to work it out. So if you have any calculator, you can punch this on your calculus, and it will give you the answer for this one. So by here, we are not having any calculus, so we are going to still convert this one to its lowest form. Having the using the calculus always help you know how you are going to reduce what this one, how you are going to find the numerical value for what this. Okay, so 256 here, the base is what 4. So in order to take away the log and the base and the number, we have to do something to this one to get what number 4, so that 4 and this log to base 4 will what cancel out, and the number that will remain is what will be the what the value for what log 256 base 4. So 256, how are we going to reduce it? First of all, let's use the base here. Let's try and use the base here to divide it. Even I think 16 times 16, I think will give us what 256. 256. So if we split this one into 16 times 16, that will give us what 256. So when we split this, we are going to get 216s. That is 16 times 16. And then we know how to convert 16. We know how to rewrite 16. That is 2 raised to the power what 4. 2 raised to the power what 4, right? So here, using what I've just said, when you multiply 16 by 16 to give you this, so 16 by 16 will give us this. Then let's write the 16 in the form of base and power. We are having 16 times 16, and it can be written as 16 raised to the power what 2. And also we know that we can write 16 as what 2 raised to the power 4. But when we do that, we are going to get 2 raised to the power 4 times 2, and that will give us what 2 raised to the power what 8. Now when we do that, the base of this one is 4, and what the another form for 256 will be what 2 raised to the power 8. When we apply the law of exponent, the 8 will come at the back here, and it won't take away the log and the base because 2 and 4 are not the same. So that is why I said the best way to reduce this one is to, let's say, use what 4 to reduce this one. Okay, and if you want to do that, if you don't have calculator, you can use the prime factor tree to do that. So using the same preamble, 16 times 16 will give us what 16 raised to the power 2, and 16 can also be written as, in terms of this base, in terms of this 4 here, 16 can be written as 4 raised to the power 2. 4 raised to the power 2. And already we are having another 2 there. So we are going to get 4 raised to the power 2 times 2. And that will give us 4 raised to the power 4. 4 raised to the power 4. Reducing this one, rewriting this one in a form of base and a power won't be all that easy. Some of us, it won't be all that easy for us to know what actually we should do to this one in order to get a base and a power. Okay, so but when you are able to reduce it, maybe 16 and 16, actually when you are asked to rewrite 16 in the form of base and power, you know that with 16, 4 times 4 is 16, so that will give you 4 raised to the power 2, and that power 2 is already being multiplied by another 2, so and that one will give us what 4. So 2 raised to the 256 can be written as 4 raised to the power 4. 4 raised to the power 4. Okay, so log 1296 base x is equal to 4 log 4 raised to the power 4 base 4. Good. Good. And now looking at this is very simple. If we read it from this direction, you can see that it looks like yeah, we are building the 4 up, like we are building story building. This is the ground floor, first floor, and then that of fourth, second floor. In terms of something like this, provided this one is written like is here, it could have become something we call tetration. But don't worry, I will you know, you know, we will do something like that tetration also for you to know what is it about. What is it about? Maybe you might have come across, but I don't know that that is what we call what's the tetration. Okay, so let's continue. Now, from the laws of logarithm, one of the laws, we have about 3 or 4 laws. One of them says that is the law of what? Exponent. The law of exponent. The law of exponent says that if you are having log, let's say a raised to the power b, it can be written as b log a, b log a. So applying that log here, we are going to assume this is what? A, and this is what? B. Just forget about the base. We are going to assume this is A and this is what? B. So it can be written as B raised to the power B multiplied by log A. So applying the same thing here, this one can be written as 4, which is the B, log A, which is what? The 4 here. So this log 1296 basex is equal to 4 log 4 base 4. Good. Now you see, writing it this way has helped us, get the same, get the number and the base to be the same. And in that instance, or in this case, the log and this number will what? Cancel out because the base and the number are what? The same. From the laws of logarithm, when the base and the number are the same, it cancel out, and whatever is left is what? The value, or is the answer. Okay, so but whatever will be left for this one after the cancellation of this and this is not the actual answer we are looking for, but is the answer to the what? This one, or is the value of what? This one, in terms of what? Numbers. Okay. Okay, so from the one of the laws of logarithm, or maybe the properties, log a base a is equal to 1. So when you apply that one here, log 4 base 4 is equal to what? 1. That means this and this will cancel, it will give you 1. 4 multiplied by 1 will give us what? 4. So log 1296 base x is equal to 4, is equal to 4. Okay, now looking at this one is though where the axis and the figure here can scared us a bit, but looking at the first one and this one, you could see that this one is a little bit easy to solve than the first one. Okay, the first one, the numbers that were involved, you could find yourself wanting how to reduce them if it is not help of calculator, or if you don't use calculator, if you find it difficult knowing what to do. All right, log 1296 base x is equal to 4, is equal to 4. Here, How are we going to find the value of x? Any idea? What do you think? All right, the idea here is that in order to get the value of what? X, we have to apply the definition of what? Logarithm. And I have already told you that in applying the definition of logarithm, it simply means, it simply means you are to raise this x by powering it what? 4, which will give you what? The number here. That is the application of what? The definition of logarithm here. You know, the definition is log of a number, say a, assuming the base is, let's say, c, is the index to which the base, which is in this case c, must be raised to give the number what? A, assuming it was equated to, let's say, b. So is the index to which the base must be raised by powering it what? C, to give the number what? A. So to find this x here, or to get this number here, we are going to raise this base by powering it to what? 4. And when we power it with 4, whatever we get will be the same thing as what? This one. Or it will, when we power it with 4, it's going to give us what? This number here. But the other time, remember I told you that when you say it in this way, that maybe 1000 from the definition of logarithm, 1290 is equal to x raised to the power 4. Some of us, don't really get it very well. Though they can just, anytime they get something like that, they can just, recall, brainstorm, and then recall. But the person that just brainstorm, but he doesn't actually know what it means. All he knows that his teacher, when he raised something like that, he just do it this way, just do it this way, but actually don't know the rationale behind. Okay, so in order to know how this one log x is eliminated, in order to get this one at the end of the day, I've told you that in applying the definition, you just take the base of that log, that log, and use it to write another base and a power. When I say if you were to write in the form of indices, like in the form of indices, what I mean is base and a power. Base and a power means we will just take this base and then you write it as x, and then we power that x with the whole of this, and with equation, whatever you do to the right hand side has to be applied to the left hand side also. So when we do that one here, you apply the same thing here. Okay, so we will write the base, which is what x. I said we always do what I'm saying with respect to whatever is written as what? The base. That one actually explains the definition, how the definition is what? Applied, or what the definition actually what means. Okay, so here actually this one will be equal to x raised to the power 4, but I'm going to show you how this log get vanished, how this log base x what vanish, in order to in order to what? Get this one remain. So as I said, we are going to take this base, which is what? X, and then we will write that one as a base, and then we will power it with what? This one on the left hand side, and then we will come to the right hand side, we write the same x, and then we power it with what? This 4 here. And after computation, you could see that that base and this log will go away, and to be left with what? This one. So let me write what saying down for you. So we are going to take x of both sides. Take x of both sides. Taking x of both sides means you are applying the definition of logarithm. Okay, and remember I said I want to show you what the definition means, or what the definition actually what means. So that is why I'm taking s of both what sides. So let's take s of both sides, and you see what I'm talking about. The moment you take s of both sides, you could see that another property of what logarithm will also be what shown here, and you apply that one, and that log x and that base will just get vanished, and you get your number back. So let's take x of both sides. Good. Definition of logarithm simply means we are to raise the base with what? Raise the base by a parameter what? Whatever is here. That is the 4 here. And when we do that, you're just going to get this one is equal to what? This. But how did this log base s get vanished? Is because of what? This one. Is because of what? This format. The moment you write it this way, it becomes another property of logarithm. That is a raised to the power log, let's say b base a, will give you what? B will give you what? B, another property or another law of logarithm. That is what it says. So if you apply that one here, that is a raised to the power log b base a. That log base a and this and the a will cancel out, and it will be left with what? Your b. So in this case, applying it here, this one is our a, and this one is also our a, and this one is our b. So you could see that this and this will cancel out, and it will be left with what? X. It will be left with 1296. Okay, so the x always get vanished when you write it what? This way. Log base x always get vanished when you write it what? This way. So since this and this are the same, it cancel out. So this will take away what? This one, and it will be left with what? This one, and that this one will be equal to this, and that tells or reflects the actual definition of what, or the actual application of what? Logarithm. Actual application of the definition of what? Logarithm. Okay, so we are going to get x raised to the power 4 is equal to 1296. 1296. X raised to the power 4 is equal to 1296. How do we find the value of x? Okay, here is very simple. It's very simple. You can take the fourth root of both sides. You take fourth root of this, also take fourth root of this, and you get your answer at the end of the day. But because here I'm using the law of exponent indirectly, which is indices, because x raised to the power 4, I'm going to punch this one to a form like this. Yeah, I'm going to rewrite this one in a form like this, like a base and what? A power. Okay, so how are you going to do that? When you reach here, you can just take fourth root of both sides, and whatever you do, just write it as your, whatever you get, you just write it as your final answer. But I'm not going to do that. I'm not going to take fourth root of, also because I'm not having a calculator, yeah, when you have calculator, just punch it and you get your answer. Okay, so 1296 can be written as 6 raised to the power 4, 6 raised to the power 4, 6 raised to the power 4. So x raised to the power 4 is equal to, now we are going to rewrite this, and I said it can be written as 6 raised to the power 4, 6 raised to the power 4. Now, by exponential equation, from the indices, when the powers are the same, but from exponential equation, when the powers are the same, we assume that the base 2 are also the same. So here we are having a power of 4, here too we are also having a power of 4. And by exponential equation, since the powers are the same, we assume that the base 2 are also what? The same. So therefore, x is equal to what? 6. So by exponential equation, x is equal to 6. X is equal to 6. And when you take your maybe your fall fruit, you could see that is what you are going to get. That is what you are going to get. Therefore, x is equal to 6. X is equal to, from the equation, the value of x from the equation is what? 6. 6. The moment we plug in 6 into the equation, you could see that both left and right hand side will give us what? The same thing. Okay. I could see it was very simple. The steps involved were very simple. Well, when you look at the question, you might think that it is very difficult. How am I going to do it? So I'm going to fail, something like that. But the moment you start working it out, you see that it's not all that difficult. Though the figures were just big. If you look at the figures, it might confuse you and you might lose what? Confidence. Yeah, you lose confidence in solving the question. How are you going to punch these figures? Okay, so guys, the value of x from the equation is what? 6. And I'll leave that one to you. You plug in the 6 and then reduce both of them. You will see that both left and right hand side will be what? The same. Will be the same. Will be the same. Alright, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.